Hello dear students, I welcome you all to the 4th edition of online class on set theory class 11 mathematics. Okay, so far we have seen operations on sets, that is union, intersection, difference, symmetric difference and the complement of a set, right? And we have seen how to draw the Venn diagram of those operations, right? Now based on that we are going to start the exercise, and the exercise number is 1.3. Alright, so let's see the first questions. So question number 2 says, if A, okay, so let me write down what are the sets given here. So we have okay, so these are the two sets given. Now let us see what are these sets in roster form. So according to this x is a natural number, so that it is lying in between 1 and 6. Okay, so if I want to show you this in a number line, so we have got 1 here, okay, 2, 3, 4, 5, 6. Alright, now if you see here, it is said that x1 is strictly less than x. That means the value of x cannot be 1. Okay, so this cannot be my value. Alright, now x is greater than 1. In other way, if I read, this is x is greater than 1. Now what is the number, or what are the numbers which are greater than 1? The natural numbers greater than 1 are 2. So 2 can be my answer. 3, 4, 5, 6 can be my answer, because x is equal to 6. Okay, but it cannot exceed 6 because x is less than 6. Alright, so that's why this set contains the elements what? 2, 3, 4, 5 and 6. 2, 3, 4, 5 and 6. Okay, so this is my set A. Now let's see what is my set B. Set B is also a set containing element x. Now this x is a natural number lying in between 6 and 10. Okay, so let me extend this. 7, 8, 9, 10. Okay, so the value of x cannot be equals to 6, because 6 is strictly less than x. There is no equal to sign, so that's why this cannot be there in the set. Now 6 is less than x, or in other words, x is greater than 6. Okay, so if x is greater than 6, then the natural number which is greater than 6 is 7, 8, 9, 10. Now let's see whether the value of x can be 10 or not. We don't have equal to sign here. That means x is less than 10. So that's why this cannot be my answer. So this set contains only 3 elements, that is 7, 8 and 9. I hope the thing is clear to you. Okay, now let's see what do the question is asking. So question is asking find A union B. Okay, so therefore A union B will be, let's combine both the sets. Yes. Okay, so by combining we see that it will be 2, 3, 4, 5, 6, 7, 8, 9. So this will be A union B, your A intersection B. Is there anything common over there? Can see anything common? Intersection means we have to write the common elements. We don't have anything common over there, so that's why this becomes your empty set phi. Next is A minus B. Okay, so A minus B means elements of A which are not in B. Now all these elements are not present in this, isn't it? So that's why we have this equals to 2, 3, 4, 5 and 6. I hope the thing is clear to you. Elements of A which are not in B. Now these are the elements of A which are not in B, isn't it? And similarly we need to write what is B minus A. So B minus A means elements of B which are not in A. Now all these elements of B are not in A. So that's why the value of this will be a set with the elements 7, 8, 9. Alright, pause the video and note it down. So the next question says Which of the following pairs of sets are disjoint? Now disjoint set means the sets, okay, so we have to take a pair of sets, and if there is nothing in common, then such kind of sets are known as disjoint sets. Let's have a look at the first one. So this set and this set, are they disjoint? Let's check. If there is anything common, or if I find the intersection to be non-empty, then they are not disjoint. Okay, so if you see here, this is common because this is set of vowels, and in this we find that there is one more vowel, right? That means this and this, they are common, so that's why they are not disjoint pairs. All right, now let's see this one. So here we see that all are even, isn't it? And here we see that all are odd, so that's why this is a disjoint pair of sets. Let's see this one. So this means this is given directly, this is 1 2 3 4, set with 1 2 3 4. Now if you convert this into roster form, you will see that the value of x is lying in, see, x is a natural number lying in between 4 and 6, and the value of x can be 4 also and 6 also, because there is equal to sign here, right? So that means this can be written as 4 5 and 6, isn't it? Now is there anything common between this set and that set? Yes, we see that 4 is common, right? So that's why they do not form disjoint pair of sets. Let's have a look at this. Obviously this set contains only even integers and this set contains only odd integers, so that's why this forms disjoint pair of sets. All right, now let me take question number 5. Question 5 says, if A and B are two sets such that A is a subset of B. All right, so let me write what is given to us. So given is A is a subset of B. Then what is, there are two parts, that is A union B will be how much? That's what you need to see. And number 2 is what will be A intersection B. Now let's see how much do we get. Now let's take one random example out here. Okay, so they are not asking us to prove here, so we can take example. All right, so okay, so A is a subset of B, right? So that's why I am taking first B. So let me take B equals to 1 2 3 4 5. All right, okay, so we have A to be the subset, so let me choose few elements. For example, let me choose only 2 and 3. All right, so we can say, or we say that 2 3, this set is a subset of this. Okay, now let's see what will be A union B. That means we are combining these two. Now when we combine the sets, we have to combine the elements, right? So after combining, we see that if I put 2 and 3 in this, we cannot repeat 2 and 3 because 2 and 3, they are already present here. So that's why this will turn out to be 1 2 3 4 5, isn't it? Now initially in the question this set is not given, we have taken this for our reference, right? Now what is this set? This set is actually set B, isn't it? So that's why according to question, what we need to show is that A union B will always be equals to B if A is a subset of B. All right, now next is A intersection B. So A intersection B means what is the common thing between A and B, and what are the elements which are common? That is 2 and 3, isn't it? So we have, this is 2 and 3, but what is this set actually? Because this set is initially not given, we have taken for reference. So instead of this, what we are going to write is this is equals to A, right? So that's why intersection will always be equals to A. Now from here, what you need to understand is, if A is a subset of B, if A is a subset of B, that means B is a bigger set, right? Then their union will always be equals to the bigger set, that is B. And their intersection will always be the smaller set, that is A. Alright, so that's what we need to understand here. Pause the video and note it down. Let's take question number 7. So question number 7 says, let xi be the set of all triangles in a plane. So xi is the set of all triangles in a plane. Now what do you mean by xi? Xi is the universal set, remember that. If A is the set of all triangles in the plane, in the same plane with at least one angle different from 60 degree. What is A dash? Okay, so that is A dash means A complement. So that's what we need to find. Now let's try to understand the question here. All right. So xi is given. Okay, so this is my xi. Xi is given to be the universal set. So if I have to draw the Venn diagram, this is how it looks. So this is my universal, and in this universal set we have set of all triangles possible. Okay, so there are many triangles present in this. Okay, now there is a set A. Okay, so this is my set A. Now this set contains triangles with at least one angle different from 60 degree. Now let's try to understand what is the meaning of this. So remember, at least means minimum, okay, and at most means maximum. All right. Now according to question, this set contains those triangles whose one of the angle, okay, or at least one angle is different from 60 degree. That means minimum one angle has to be different from 60 degree. Are you understanding my case? At least minimum of one angle has to be different than 60 degree. That means if minimum is 1, at least 1 means minimum one angle has to be different than 60, then we can have two angle also different than 60 degree, or we can have three angles also different than 60 degree. Are you understanding? Minimum has to be 1, okay, minimum one angle has to be different than 60 degree. That means maximum there is no limit. That means all the three angles can also be different than 60 degree. So that means this A contains those elements which are not equilateral. Are you understanding? Because in equilateral triangle what happens is all are 60 degree, all are 60 degree, and these elements do not fall under this, because in this none of them, in equilateral triangle none of the angle is different than 60 degree. So basically this angle do not contain equilateral triangle. All right. So set A is what actually? Set A is set of all non-equilateral triangle. Okay, so this set, that is this set contains all non-equilateral triangle. Okay, so non-equilateral triangles. Okay, that means whatever is coming outside this, that is this part here, must lie only the equilateral triangle, and actually this gives me what? This gives me A complement, isn't it? So therefore your A complement will be set of all equilateral triangles. All right, so this is what we need here. All right, so pause the video and note it down. So let's take question number 9. So question 9 says, from the adjoining Venn diagram write the following, that is A dash. Okay, so let's see what will be my A dash. This is question number 9. Okay, so this one is my A. So apart from this, whatever elements, that means outside this A, whatever elements are there, those are my A complement, isn't it? So outside this we have got the elements 1, 5, 6, 7, 9, isn't it? So if I put them in a set, that gives me the A dash. Okay, so A dash will be the set containing the element 1, 5, 6, 7, 9. Okay, so 1, 5, 6, 7, 9. All right, the next part is, this is my first one. So next one is, they are asking us to find what is B dash. So the elements outside B. So this is my B. So outside this B we have got the elements 2, 4, 1, 7, 9. All right. So if you want to write in order, that will be better. So 1, 2, 4, 7, 9. All right. So 1, 2, 4, 7, 9. So this will be your B dash, and the last one is this one. All right, so we need to calculate this, but before that we need to see what is our A intersection B. Okay, so we have A intersection B is this part, isn't it? And within this, what is lying? 3, 0 and 8. Yes. So the complement of this set, please be careful with this. So the complement of this set will be what? The elements outside this. And what are the elements outside this? The elements outside this are 1, 2, 4, 5, 6, 7 and 9, isn't it? So that's what will be my answer for this one. So the elements outside this are 1, 2, 4, 1, 2, 4, 5, 6, 7, 9. 5, 6, 7 and 9. Alright, so this will be your answer for this particular question. Pause the video and note it down. So dear students, be very attentive with this question. Question says, this is question number 10. What is represented by the shaded region in each of the following Venn diagrams? So there are 4 Venn diagrams given to you and you need to tell me what do these shaded portion represent. Okay, so this is very simple. We have already seen this and this is your A delta B. A delta B means this is symmetric difference. You already know that. But we have got these 3 which looks a bit difficult, but it's not so. It's going to be simple. Let's see how. Now, you see that whole part of A is shaded, right? Now, this A is combined with this part, isn't it? So combined means what? Union. That means you are taking union of A with something else. Are you understanding my point? A, everything is shaded, right? So if everything is shaded, let me write A in the beginning itself. Okay. Now it is combined with this part, isn't it? See? Yes. Now combined means what? Union. Alright. Now what is this part? Now we don't know what is this part. So let's take all these part, this full thing. And what is this actually? This is your B intersection C, isn't it? So this represent this set, alright. So A union with B intersection C. So I am taking union of this with B intersection C, that is this much, alright. So this will be your set for this Venn diagram, alright. Let's have a look at this. Now if you see this, here we have got C, right, and this, how much ever is shaded, the entire thing belongs to C, yes, but whole C is not present, please remember that. This part of the C is not included, so only this part of C is included, alright. So that means what is happening here? Some common part is taken for C, isn't it? So I am taking C, and since you are taking the common part, that is only this much part, I am taking intersection out here. Okay, now intersection with what? Intersection with, let's see what do we get out here. So we have got the other set to be this much. Yes. Okay, now we have got these 2 sets here. So forget about C. Alright, now from this, if I choose only intersection of these 2, B and A, the intersection will be this for B and A, yes. But if you see here, this part is not included, right? So only this part is included. Alright, now I don't know how much will be this part. Alright, I don't know that. So what am I going to do is, I am going to take everything. So this everything gives me my A intersection B, I am sorry, A union B, yes. So if this is my A union B, this full thing, if this is my A union B, and if this is my C, alright, then if I take the intersection of C and A union B, only common part will be the shaded part which is given in the question, isn't it? So that's why this will be set C intersection A union B. The common part between A union B, that is this full shaded part, and this set C. So the shaded part is the intersection, that is the common between C and A union B. Alright. Now this and this both are similar, so this you will try by yourself. Pause the video and note it down. Let me take question number 11. So question number 11 says, if xi, that is your universal set, is given, A is given and B is given, all are given in set builder form. Now let's try to convert them into roster form. Okay, so we have question number 11 given. So these are the three sets given to you. So you need to find, or you need to draw a Venn diagram to show the relationship between the given sets. So let's see how do these are related. Alright, so let's see what is my universal set first. So universal set is given to be this set where this x is a natural number less than or equals to 8. Alright, so my set contains, since it is natural number less than or equals to 8, the natural number less than or equals to 8 are 1, 2, 3, 4, 5, 6, 7 and 8. Alright, next is A and B are given. That means A and B must be subset of universal set. Okay, now let's see how this A is given. So A is containing those elements such that its square must be lying in between 8 and 40. Okay, so let's choose the value of x to be 1. So 1 square is how much? 1 square is 1. Now 8 is less than 1 is not valid. Alright, similarly choose 2. Now square it. 2 square is 4. Now 8 is less than 4. That's also not possible. Next is 3. So 3 square is 9. So 8 is less than 9 and 9 is less than 40. So we can have my element to be 3. Alright. Similarly, let's take 4. So 4 is 16. So 16 is lying in between 8 and 40. So that's why 4 is also included. Don't write 16, 9 and all. Alright. Because we are checking the value of x. Next value for x is 5. Okay. So 5 square is 25, which again satisfies this. So 5 also comes within this. Next is 6, right? So 6 square is 36 and again 36 is lying in between 8 and 40. So that's why 6 also comes here. Next is 7. So 7 square is 49. 49 is less than 40. Is this true? No. This is false. So that's why 7 and 8, they will not be included in this set. So that's why my set A becomes this much. Next is B is a set. This, now what is B actually? B is a set with element x such that x is an odd integer. Now again, since B is subset of universal set, now what are the odd integers out here? The odd integers are 1, 3, 4, 1, 3, 5 and 7. Isn't it? Okay, now in order to draw the Venn diagram, let's see whether there is anything common. See, first and foremost, what do we need to do is we need to draw this rectangular box, and this is my universal set, right? Okay, now let's check if there anything is common between A and B. Is there anything common? Yes, so we see that 3 and 5, they are common, so that's why they will be intersecting. Okay, so set A and set B will be intersecting each other. Okay, and what are the common elements? 3 and 5 are common, so this will come here. Okay, so this is the common region between A and B. So 3 and 5 are common, so that's why they will be written here. Now in A, what are the elements other than 3 and 5? The other elements are 4 and 6. So 4 and 6 will be placed here within A only. And within B, what are the elements other than 3 and 5? They are 1 and 7. So 1 and 7 will be written out here. Okay, so how many elements are covered? 1, 2, 3, 4, 5, 6. 6 elements are already written. How many elements are there? 8 elements are there, isn't it? Now let's see what are the elements which are not written. So 1 is written, 2 is not written, so that's why 2 will be kept outside A and B. Okay, we have 3 already written, 4 is written, 5 is written, 6 is also written, 7 is also written, 8 is not written. So 8 will come outside A and B. So you can place 8 anywhere outside A and B. So this will be the Venn diagram depicting the relationship between A and B in relation to the universal set xi. Pause the video and note it down. Let's take question number 13. So question 13 says, if the universal set is given to be the set with elements 1, 2, 3 till 10. Okay, so let me note down what are the sets given to us. So this is question number 13. Okay, so These are the sets given to us. This is my universal set and A and B are subsets of this universal set. So we need to calculate what are the values of this. Let's see how to evaluate this. First and foremost, we have to write down this in roster form. So since A is a subset of this, that is universal set, what am I going to do is I am going to choose all the prime numbers, okay, from this and put within this set. So this set becomes my set A. Now what are the prime numbers? The prime numbers are 2, 3, 5, 7, isn't it? Only these are the prime numbers. 2, 3, 5, 7, 8 is not a prime number, 9 is also not a prime number. So these are the only prime numbers. Now this is my set A. Now set B is the set with even integer. Alright, so what are the even integer? From here the even integers are 2, 4, 6, 8 and 10, isn't it? Now what we need to find is A minus B. So A is already there, B is already there. So A minus B means elements of A which are not in B. Now since B contains only even, we need to eliminate even from here. So we have only 2 as the even. That means these are the elements of B which are not present in, these are the elements of A which are not present in B. So that's why this set will be 3, 5 and 7. Now in order to evaluate this, first we need to see what is B dash. Okay, so let's write B dash out here. So B dash will be equals to how much? B dash will be, see, elements other than this, alright, elements of universal set, because this means U or universal set, that is xi minus B, isn't it? This is the definition of complement. Now xi means these elements, yes, so elements of this which are not present in B. So the elements of this which are not present in this are, since all are even, now we need to write down only the odd integers out here, right? So you are removing all the even integers from universal set. So that's why you will get all the odd integers, that is 1, 3, 5, 7 and 9. So this will be your B dash. Now you are finding what are the common elements between A and B dash. Okay, so A is there, B dash is here. Now what are the common elements? Let's see. So 3 is common, yes, 3 is common, 5 is common, 7 is common. Is there anything common? No. So this contains again 3, 5 and 7. Alright, so these are your answers. Now before you start copying, I want to say something out here. You see that both are equal, isn't it? Both are same. So that's why there is a very important result that we are going to prove in the upcoming few classes, and from there we are going to prove one very important result, that is called A minus B will be always equals to A intersection B dash. So this is one of the very important formula as well. Pause the video and note it down. Now let's take question number 16. It's going to be a bit tricky questions, because the same kind of question you may face during your competitive exams as well. So let me read the question for you. Question says, on the real axis, that is real line, if A is given to be 16. So given is A is given to be open 0, 3 closed. So we read this as open close 0, 3. Okay, so A is given to be this and B is given to be 2 closed 2, 6. Okay, so these two are given. So you need to write down what is A union B, what is A intersection B, what is A minus B and what is B minus A. Let's see how to do this. So before we start writing that particular set, what we are going to do is, let's write down this in set builder form. Right? Now since 0 is not included, this means x, so that x belongs to real number R and 0 is less than x and less than or equal to, because this closed, so 3 will be written here. Alright, so this becomes x such that x belongs to R and first is 2. Now since this is closed, so that's why we have to write less than or equals to x less than or equals to 6. Alright, so these are the set builder notation of these two intervals. Okay. Now what we need to do is we need to write what is A union B, A intersection B, A minus B and B minus A. So before that, let me draw a real line. Alright, so what are the points given here? 0 is given, 2, 3, 6. So let me write where is 0. So let me write 0 to be here, 2 to be here, 3 to be here and 6 to be here. Alright, now let's write down what is set A. Set A is 0, 3. So 0 is not included, so that's why I need to exclude this. Alright, so 0 is excluded. So in order to exclude, we need to put a circle like this. Next is 3. So 3 is lying out here, so we have to put this kind of circle, dark circle. So this represents, okay, so this represents your set A. Alright, so this represents your set A, and next is 2 to 6. So 2 is given there. So 2 is given out here, yes, and 6 is given out here, and both of them are included, so that's why I am doing this. So this line represents your set B. I hope the figure is clear to you all. Okay, very good. So next is what we need to find is number 1, what is your A union B. So basically we need to combine both the sets, isn't it? So one set is from here to here and another set is from here to here. So if we combine them, this set becomes from here to here, isn't it? So what is this? See, 0 is not included here, isn't it? So it will be open, this is 6 which is included. So open closed 0 comma 6 will be my answer for this. Okay, so open 0 comma 6 and we have to close it. I hope the question is clear to you all. Okay, so number 2 is A intersection B, the common part. So this is my set A, this is my set B, and what is common between them? The common part is only this much, isn't it? And what is this actually? This is 2 to 3, and since 2 is also included and 3 is also included, it will be closed interval out here. Okay, so closed interval 2 comma 3 will be your A intersection B. Alright, next number 3. So it says we need to find what is A minus B. Alright, now elements of A which are not in B. So these are the elements of A which are not in B, isn't it? Yes. Now what is this part? This is, see, this is 0, it is open, right? Now can you write this? This is my question, because we have till here is 2, isn't it? So can we include 2? No, because 2, if I choose this, 2 is included in this set, yes, but we are writing the elements of A which are not in B, but we see that in B we have got 2 also, right? Are you understanding? In B we have got 2, isn't it? So that's why 2 should not be present out here. So that's why to exclude 2 we have to make it open interval. Okay, so my answer for this will be open 0, 2. Okay, and the last one is B minus A. So let's see what is B minus A. So B minus A means elements of B which are not in A. So these are the elements of B which are not in A. Okay, so again 3 has to be excluded. Alright, and 6 is already not present in A, isn't it? Are you understanding? Now why am I excluding 3? Because if I include 3, then this A already contains 3, because there is a closed interval, right? So that's why I need to exclude 3. So that's why I put open out here. Alright, so that's why my answer for this will be open closed 3 comma 6. Okay, pause the video and note it down. So let me take question number 18. So question C is, if A equals to the set of letters in the word Jaipur. So A is a set which contains the letters of the word Jaipur. Now in Jaipur we see that all the letters are distinct, none of them are repeating, so that's why all the letters are coming inside the set. and B equals to the set of letters in the word Jodhpur. So Jodhpur also contains all distinct letters, so that's why set B is written in this way. Okay, so you need to find A union B, A intersection B, A minus B and B minus A. Alright, so let's first find that and also verify the following results. That part we'll see later. Okay, so let's find quickly what is A minus B. So we have, this is A union B. So A union B means combine the sets. So J is present, yes, A, yes, so A is written, A is not present out here, I is written, P, U, okay, so let me write first Jaipur. Now, while coming to Jodhpur, J is already written, O is not written, right? D is not written, H is also not written, so D, H will also come. P is already written, U is also already written, R is also written. So this will be your A union B. Alright, we have A intersection B. So A intersection B means what are the things which are common. So we see that J is common, A is not present here, I is also not present, P is present, U is present, R is also present. So this will be your A intersection B. Next is number 3, that is A minus B. Okay, so A minus B is given to be, see here, the elements of A which are not in B. Okay, so what are the elements of A which are not in B? They are A and I, isn't it? So it will be A comma I. Alright, next is number 4, that is B minus A. So B minus A is how much? Let's see. So elements of B which are not in A. Now what are the elements of B which are not in A? They are these three, isn't it? Yes. So we have O, B and H. So these are your A union B, intersection B, A minus B and B minus A. Now the next part says verify the following results. So what are the results? Let me see. So we have N of A union B, that is cardinality of A union B. So let us see what is cardinality of A union B. So it is N of A union B is, let's see how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, so this is 9. Okay, so this N of A union B is equals to N of A plus N of B minus N of A intersection B. Okay, so let us see what is N of A. So from here we see that cardinality of A. How many elements are there? 1, 2, 3, 4, 5, 6. Alright, and what is N of B? Cardinality of B will be equals to 1, 2, 3, 4, 5, 6, 7. Alright. Okay, so we got N of, okay, so we will find N of A intersection B as well. Cardinality of A intersection B. How many elements are there? 4 elements are there. So this will be equals to 4. Alright. So next is, see, we have not verified, we have just written down the cardinality. Now next we need to write down the cardinality of N of A minus B. Okay, N of B minus A is not mentioned anywhere, so let's not find that. So we have N of A minus B. How many elements are there? So we have got exactly 2 elements. Alright, so let's see the first one. So first one is N of A union B is equals to N of A plus N of B minus N of A intersection B. I'll do only this one. The other part, the second one, you will try by yourself. Okay, so left hand side contains N of A union B, and how much is this? So this is equals to N of A union B is equals to 9, isn't it? So right hand side has N of A plus N of B minus N of A intersection B. Now let us put the values. So what is N of A? N of A is 6 plus N of B is 7 minus N of A intersection B is 4. So let's add them up. So this plus this is 13. So 13 minus 4 is how much? This is equals to 9. See, this is also 9, this is also 9. Hence, this is verified. Alright, pause the video and note it down. Try the second part by yourself. So let's take question number 20. So question number 20 says if your universal set is this, A is this, B, C, if 3 sets are given to be this much, now you need to see there are 12 questions, 12 sub questions, but I am taking just the last 3, okay, that is 10, 11 and 12. So let's evaluate how much is this going to be. So here we need to see there are brackets, so we need to follow Bodmar's rule. Alright, so Bodmar says finish off with your brackets. So whatever is there inside bracket, let's see what is that. So we have A union B. So let's find what is A union B. So A union B, that means combine A and B. So you will see that it will be 1, 2, 3, 4, 5. Isn't it? So when you combine these two, we have 1, 3, 5. So basically A is a subset of B. Yes. So that's why this will be equal to this much. Okay. And you are finding the intersection of this. Okay. Intersection of this with C. Okay. And what is C? C is this. So basically you are finding intersection of this and this. That is the common element. And what are the common element out here? So you see that only 4 is the common. So that's why this will be, and this will be a set with the element only 4. Alright. Now let's see what is this. So we have, okay, so let me erase this. We don't need this. Next we have A intersection B. So let's find what is A intersection B first. So, okay, so let me write this because we need this. We have 1, 2, 3, 4, 5. So let's write what is A intersection B. That means common elements between this. So it will be 1, 3, 5. Yes. Now we have this. Now let's see what is C dash. C is this, isn't it? So C dash means subtract C from universal set. That means remove these elements from this. Alright. So if I remove, then we have C dash will be 0, 1, 2, 3, 4 is already there. So need not written. 5 is not present. So 5, 6 should be eliminated. 7 and 9 has to be included. 7 and 9. Alright. So this is your C dash. Now you have to take the intersection of this, that is this, and C dash. Alright. So what are the elements common? So the common elements are 1, 3 and 5, because 1, 3 and 5 they are also present out here. So this will be a set with elements 1, 3 and 5. Okay. Now next is take the intersection of A union B, which is already found. We need to find what is A intersection C, A union C as well. Alright. So let me erase this. So we have A union C. So let's see what is A union C. So let's combine A and C. So after combining we get 1, 3, 4, 5, 6, 8, right? So we have 1, 3, 4, 5, 6 and 8. Alright. Now you need to take intersection between this A intersection A union C, that is this, and A union B, that is this. So what are the elements common in between these two? The elements common are 1 is common. So let me write down 1. 2 is present here, but it is not present here. So that means 2 is not common. 3 is present here. Here also it is present. So 3 is coming here. 4 is there. 5 is also there. Yes. Now we don't have any other elements which are common. Alright. So these are the answer for this 3 particular cases. Now you will try the rest of this particular question, that is question number 20, by yourself. Pause the video and note it down. Alright, so let me take the last question for the day, that is question number 23. Question says, if xi equals to the set of all digits in our decimal system, A is this set, B is also written out here, then verify the following results. So there are 6 results given out here. I will just show 2 to 3 results, rest you will try by yourself. Okay. Now here let me convert this into our roster form. Alright. So set of all digits in decimal system. Decimal means deci means 10, isn't it? So we are going to write okay, so dear students, so we are going to do the last problem. So let me take the last question for the day, that is question number 23. So question says, if xi is a set of all digits in the decimal system, that is our universal set is given to this one, A is given to this, B is given to this, you need to verify the few results. There are 6 results given to you, so you need to verify them. Okay, I will take few results, others you will try by yourself. So first and foremost, let's convert this into roster form. Xi is the set of all digits in decimal system. So decimal system means the numbers starting from 0, 1, 2 and continues till 9. Okay, so basically a single digit number they are talking about. So we need to take A. A is the set containing only prime number, and out of these numbers, what are the prime numbers? The prime numbers are 2, 3, 5, 7, right? So that's all is the prime number, and we have next is x, okay, and this x has to be a perfect square. Now here what are the numbers which are perfect square? Numbers which are perfect squares are 0 square is how much? 0 square is 0 itself, right? So that's why this 0 can be written as 0 square, so that's why 0 can be taken as perfect square. Next is 1, next is 2, isn't it? No, 2 is not perfect square. Next is 3, no, so 1 square is 1. Next is 4, 2 square is 4, isn't it? So we have 4 which is a perfect square. Next perfect square number will be 9. So next perfect square number is 16, but 16 is not lying here, so that's why only these many elements will be chosen for B. Okay, now we need to prove few results. Okay, so we need to verify that number 1 is A union with A dash will be equals to the universal set. Let's see whether this is true or not. Okay, so first we have A is already there, so let's find what is A dash. Elements from universal set apart from this. So what are the elements apart from this? They are 0, 1, 4, 6, 8 and 9, isn't it? Yes, now we need to find what is A union A dash. That means we need to combine A, that is this, with A dash, that is this one. So if I combine these two, then I will get 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, isn't it? And what is this set actually? This set is my universal set, right? So that's why my first result is verified, that is A union A dash will be equals to the universal set. Okay, so the next one is the intersection between A and A dash. Okay, the intersection between A and A dash will be equals to 5, that is empty set. Now A is this one and A dash is this much. Now what is the common, or what are the common elements between this and this? There is nothing common, right? So this is also verified. Since there is nothing in common, so that's why we have written 5. Okay, so we have A minus B. Okay, so we need to find what is A minus B as well. So as I said earlier, we need to find A minus B will be equals to A intersection with B dash. Let's prove this. Now this will be the last part that I am showing you. You have got 3 more parts. You will try them by yourself. So let's find what is A minus B. A minus B will be, okay, so A minus B. So elements of A which are not in B. So what are the elements of A which are not in B? The elements are 2 is not there, 3 is not there, 5 is not there, 7 is also not there. So all of them will be there here. Okay, so we have 2, 3, 5 and 7. Alright, we have A, we don't have B dash. So let's find what is B dash. So I am finding it separately. So B dash will be the elements of this which are not present in B. Okay, so those elements are 0, 1, 2, 3, 4 is there, 5, 6, 7 and 8. Alright, so these are the elements of this which are not present in B. Alright, now let's see what is the intersection, that is this one, A intersection with B dash. Let's see how much is this. So A is where? Where is A? A is here. And where is B dash? B dash is here. Now let's see what are the elements common in between these two. So the elements common are 2 is there, 3 is also there, 5 is also there, 6 is not there, 7 is there, 8 is also not there. So that's why the common elements are 2, 3, 5 and 7. Now if you see here, both are same, isn't it? So that's why this is also verified. Alright, so similarly you need to verify few more that is given in your textbook. Alright, so with this we close for the day. Try the remaining sums from the exercise in order to get familiarized with the process. Alright, with this we close for the day. Thank you very much.